Hello. So, this is lesson 5.2, Annuities, Future Value, and Sinking Funds. So, oops, okay, there's a mistake here. So this was the 5 point, actually 5.8, both of them, simple and compound interest. The old edition of the book, the 5.1 single interest, or 5.1, lesson 5.1 was a single interest, and lesson 5.2 was a compound interest. So that's why there's kind of, yeah, we're just, yeah. So again, this is different from loans and investments we studied in 5.1 because those investments start with a single lump sum. Payments are not made periodically. So that's what 5.1 was. So annuity is a sequence of equal payments made at equal periods of time. These may be to accumulate funds or to pay out funds. Okay, so we're going to first look at ordinary annuity. Payments are made at the end of each period, and the frequency of payments is the same as the frequency of compounding interest. So here's the formula for the future value of an ordinary annuity. We're not going to use this one. And again, this is in the formula sheet that you will get for your exams. So PMT is the payment at the end of each period. I is the R over M, which is R is the annual interest rate and M is the number of periods per year, and then N is the total number of periods. So a reminder that N is the same thing as M times T, and T is time in years. So let's look at this first example here. A rookie in the National Football League just signed his first 7-year contract. To prepare for his future, he deposits $350,000 at the end of each year for 7 years in an account paying 4.1% compounded annually. How much will he have on deposit after 7 years? Um, so how much will he have on deposit is our question. So we know that we are using the ordinary annuity because of this word right here. Um, so how much will he have on deposit? That is the future value. So that is what is being asked. Our payment at the end of each period is the what he deposits. So $350,000. And our T is 7 years. Our rate is 4.1%, so 0.041, and it is compounded annually. So M equals 1. I is the rate divided by M, so how many times a year compounded, and that is going to be 0.041. And our N is going to be M times T, so 1 times 7, which is 7. Okay, now we're going to take this, um, take the future value formula and plug all the numbers in. So 350,000 brackets, 1 plus, and our I is 0.041. This is inside parentheses to the power of n, and our n was calculated here, which is 7. We're going to subtract 1, and then we're going to divide this by I, which is 0.041, and all this inside brackets. Now, when we plug this in the calculator, you've got to be careful again. Make sure that you add one set of parentheses here, or so that the calculator doesn't think that you're um, or so that this whole thing is divided by the 0.041. Okay. So the future value when we plug it in the calculator is going to be 2,772,807.59. Um, so how much did he invest? So this was what was like asked. This is the answer. How much will he have on deposit? Now, just out of curiosity, he invested $350,000 per year for 7 years, and that gives him $2,450,000. Now, if we want to calculate how much interest he earned, we would take the future value that we got, $2,772,807.59, and we're gonna subtract the $2,450,000. And when we do that subtraction, we get 322,807.59. So that is how much interest. So this is the amount of interest he got during the 7 years. Again, the question was only asking how much will he have on deposit after 7 years, and that is the future value that it was asking. Okay, let's look at the next one, which is a sinking fund. So a sinking fund is again a type of ordinary annuity. A fund set up to receive periodic payments, a type of annuity, such as when a corporation or municipality sets up a fund to repay a bond issue. Um, okay, so let's look at an example. A business sets up a sinking fund. Again, this tells us that it is an ordinary annuity, so that it will be able to pay off bonds it has issued when they mature. If it deposits $12,000 at the end, so the end is again the key word for the ordinary annuity as well, end of each quarter in an account that earns 5.2% interest compounded quarterly, how much will be in the sinking fund after 10 years? Okay, it's again asking for the future value. The payment at the end of each quarter is going to be $12,000. Our M is going to be 4 because it is compounded quarterly. Our rate is 0.052, 5.2%. And now our I is going to be 0.052 divided by 4, which is 0.013. N is going to be 4 times 10, and that equals 40. So we didn't put T equals 10 over here. That's where that 10 comes from. Okay. Now, we're going to again calculate the future value. So 12,000 multiplied by 1 plus 0.052 divided by 4 to the power of 40 minus 1 over, hold on a second. Actually, we calculated this. That's why I'm confused. 0.013. That was our 1 plus I. And our I is over here. Okay, and then divide it by the I again. So 0.013, all this inside brackets, plug it into the calculator, and we get $624,369.81. Now, make sure that you know how to plug it in the calculator and to get the correct answer. And if you have any questions about using the calculator, because these calculations are not easy to make sure that you do it correctly in the calculator. So um, let me know if you have any questions about it. Okay, let's just out of curiosity look at, so how much did the business invest? It was $12,000 40 times. So the investment was $480,000. And now if we subtract if we subtract the future value or the invested money, so the $480,000 from the future value, 624,000, we get $144,369.81. So that was the interest. What it was asking is how much will be in the sinking fund. So that's the future value is the answer. Okay, next question is going to be, a firm borrows $6 million to build a small factory. The bank requires it to set up a $200,000 sinking fund to replace the roof after 15 years. If the firm's deposits earn 6% interest compounded annually, find the payment it should make at the end of each year into the sinking fund. So what is it asking right now? It is actually asking the PMT value. So the payment that is made at the end. And now again, the words sinking fund and mean that we have an ordinary annuity. Okay, our future value now is going to be the $200,000. So this amount right here. Our T is going to be 15 years. R is 6%, which is 0.06. Our M is 1, so annually. Our I is going to be R over M, so that's just going to be 0.06 divided by 1. That doesn't change. And our N is 15. So T over M, which is 15 over 1, is 15. Okay, now for this one right here on your exam, there is going to be how to calculate the PMT out of the future value. Let me just double check. hmm So what we do, yes, so PMT is going to be the future value over 1 plus I to the power of n minus 1 over I, and all this inside brackets. So basically, what we did here, um, is we took this formula that we have right here and solved for the PMT instead of the FV, the future value. So we solved it for the payments. Now we're going to plug this in, 200,000 divided by 1 plus 0.06 to the power of 15 minus 1 divided by 0.06. PMT equals $8,592.65. So that would be the payment that they need to pay after each um, compounded annually, so each year. Okay, next thing is annuities due. So annuities where payments are made at the beginning of each period. So notice the difference now between this and the ordinary annuity. And you will see it in the wording. So future value of an annuity due, here's your formula for that. It looks a little bit different than the one that we just did. And still we have our N is M times T, where T is the time in years. Okay, so let's go ahead and look at examples with this formula. Find the future value of annuity due with the given rate. So this here tells us that we're going to be using this formula right here. So payment of $1,050. So that is our PMT, 1,050 for 8 years. T is 8 years. At 0.21%. So R is 0.21%. And now we're going to move the decimal, divide by 100, even farther to the right. So 0.0021. Annually, so M equals 1. So our I is going to be 0.0021 because it doesn't change when we divide it by the 1, which is our M. Our N is going to be 8 divided by 1, which is 8. And now looking at this formula here, we don't only need N, but we need N plus 1. So N plus 1 is going to be 8 plus 1 right here. That equals 9. Okay, so let's start plugging in numbers. So 1050 brackets 1 plus 0.0021, and this was to the power of n plus 1, so that is our 9, minus 1 divided by 0.0021, and then we are subtracting one of these, so one of the payments. And that, okay, I ran out of room here. Let me see if I can do this a little bit smaller. So minus 1, here we go, minus 1050. And when we plug it in the calculator, we get $8,479.77. How much was invested? Just out of curiosity, that was 1,050 times 8, which is 8,400. So when we do the subtraction from the future value, interest is going to be $79.77. But again, It was just asking us to find the future value, which is this number right here. Okay, let's look at this next example, or our last one. A mother opened an investment account for her son on the day he was born. Investing $1,000. Each year on his birthday, she deposits another $1,000, making the last deposit on his 18th birthday. If the account paid a return rate of 5.6% compounded annually, how much is in the account at the end of the day on the son's 18th birthday? So this is going to be annuity due because it's deposited at the beginning when the son was born. Our PMT is going to be $1,000. Our R is 0.056, 5.6%. M annually, so 1. T is going to be 18 because it's on the 18th birthday. I is going to be 0.056 divided by 1, and that doesn't change. N is going to be 18 divided by 1, so that's going to be 18. And then our n plus 1 is 18 plus 1, oops, which equals 19. So our future value is going to be 1,000, 1 plus 0.056 to the power of 19 minus 1 divided by 0.056 minus 1,000. So future value, and these are dollars right here. So when we plug it in the calculator, our future value is $31,426.46. That is our answer. So if we think about this, eight, oops, 18th birthday is 19th deposit, right? So what we need to do is we need to add another $1,000 here to this number, and we get $32,426.46. And that's your answer. Okay, that's it for this lesson. Let me know if you have any questions. Bye.